Greetings to all my lecturers. Today, me and my friend Atif and Hazika are going to talk about integrated project. First of all, I'm going to talk about introduction. Syngas or synthesis gas is a fuel gas mixture consisting primarily of hydrogen and carbon monoxide and very often some carbon dioxide. The name comes from its use as intermediate. Syngas is usually a product of coal gasification and the main application of is electricity generation. Greetings to Dr. Bawari and my fellow friends. I'm H.a.m and I'm going to talk about the reaction engineering part. There is three research objectives for chemical engineering reaction 1, which is to design reaction process system for conversion of the purified natural gas, and then strategies to maximize the selectivity and yield of syngas and minimize the side reaction, and lastly strategies to purify and maximize the production of purified syngas from crude product. We use three types of reaction in this integrated project, which are steam methane reforming, dry reforming and partial oxidation. For steam methane reforming, methane reacts with water to produce 3 hydrogen and carbon monoxide, whereas for dry reforming, methane react with carbon dioxide to produce hydrogen and 2 carbon monoxide. For partial oxidation, methane react with half oxygen to produce 2 hydrogen and carbon monoxide. There are 3 types of reaction involved in this project, which is first of all it is steam methane reforming, where it is a first reaction and exothermic pressure takes place at 500 degrees Celsius. Pressure for all steam methane reforming, dry reforming and partial oxidation are constant, which is 50 atm. For dry reforming, it is a second reaction and exothermic pressure takes place at 500 degrees Celsius too. For partial oxidation, it's a third reaction and the exothermic pressure takes place at 500 degrees Celsius. The type of reactor we used in this project is plug flow reactor. Why we use PFR is it is easy to predict the behavior of chemical reactors of tubular design, and it is because it can also operate in steady state. It is also has a higher theoretical efficiency. Lastly, I'm going to talk about the process involved. The process involved in this project is differential method. The assumptions are reversible reaction without phase change, follows ideal gas law, and steam will be in excess.
Hello, my name is H.a.m and I'm in charge of explaining process modeling and simulation part. According to the task given, we have to develop mathematical models, design and stimulate for production of syngas by using symmetry simulation software. The unit reviews are PFI and Mixer. All of the details and parameters are stated in the PDF as well as for the results. With that, we found that pressure, flow rate, temperature has an effect on reaction. Due to ideal gas law, increasing the pressure will increase the conversion, whereas for flow rate, increasing the flow rate will decrease the conversion rate. Whereas for temperature, increasing the temperature will increase the activation energy, thus increasing the conversion rate. This is due to Arrhenius equation.
Hai, Assalamualaikum and salam sejahtera. My name is Muhammad Atif Shukri bin Shafi'i. I'm from Chemical Engineering Department. So today for this video, I'll be presenting about separation process 2. For separation process 2, we have 3 objectives. The first one is to design a separation process system for syngas. The second one is to sketch the diagram for membrane and specify its specification. And the third one to calculate the selectivity and flux. So today we will look at each of the objective and find out what we have done in our research. Now we move on to the first objective, which is the overall block diagram. So as you can see, our team has decided to use 3 equipments, which is valve, cooler and also membrane. In this block diagram, we already assume that our syngas is purified from any contaminants. So our syngas will go straight to the valve and then to the cooler before going into membrane. So what is actually the function of valve and cooler? The valve is used to lower down the pressure of the syngas, and the cooler is used to lower down the temperature of the syngas, because at the membrane we have the operating condition for the membrane, which is at 45 bar for pressure and temperature is 45 degrees Celsius. So the valve is used to lower down the temperature from 70.2 degrees Celsius to 75 to 41 degrees Celsius, and the cooler. And for the valve, it is used to lower down the pressure from 75 to 45 bar only. So from the diagram, you can also see the molar flow rate for each component in the overall block diagram. Moving on, let's have a look at the membrane module configuration. So for the membrane, we choose the plate and frame membrane. So the type of membrane that we use is polyamide thin film components. For your information, our membrane, the operating condition for the temperature, as I said before, is 45 degrees Celsius, and also the operating pressure is 41 bar. For your information, I choose, based on the diagram above, we have already sketched the schematic diagram of our membrane. So as you can see, the feed is flowing into the equipment and flowing to four plate of membrane, which the separation process will take place. And the concentrate, which is at the lower side, is where the carbon dioxide leave the equipment, and also the permeate side is which the other components of the syngas leave the component. With that, I think that's all with separation part and also our presentation for today. With this opportunity, I would like to say thank you to all my teammates, lecturers, family and also friends that always help me and help us to finish this project and also help us in many ways. I'm very grateful to have the opportunity to learn and research and do some learning in this project, because this project has exposed us to many real life situations that we will go through when we are working later. So thank you for the opportunity and have a nice day.